Hit record. Thank you very much. This is Dan Radonsky. I'm the CEO of Centropos Accelerator at Lawrence Technological University. Really appreciate you joining us today to hear about our Industrial Decarbonization Innovation Challenge. This is a global tech challenge that is looking for the best ideas that will reduce emissions in manufacturing operations and industrial operations, and particularly with a focus in supporting our corporate partners and broader domestic manufacturing base. So for those that are joining, please make sure you're on mute if you're not presenting. There'll be an opportunity to ask some questions. If you do have interest in asking a question or inquiring about the program or hearing directly from some of our speakers, I encourage you to use the chat function to list your question. We'll be fielding questions from the chat function, and we'll make sure to address your question in the Q&A period. The event will be recorded. It's being recorded right now, and it will be made available to all that registered and attended within 24 hours after the event. Phil, if you wouldn't mind advancing to the next slide. As mentioned, I'm with the Centropos Accelerator at Lawrence Tech University. We're a really unique accelerator program located in Michigan. And we are primarily focused on two things: helping bring new climate tech products to market, specifically hard tech products. This could be wind, solar, vehicle technologies, really anything in that whole clean tech space. We have what's known as a C3 accelerator, which stands for Clean Tech, Climate Tech, and Circular Economy products. And we're really unique in that we're the only accelerator of our kind that has in-house design, engineering, prototyping, and manufacturing readiness services. So we can take an idea that whether it comes from a startup or established firm and help design, engineer, and get the product all the way to manufacturing, and have done a really good job of that over the last 6 years and getting more products made in Michigan or more broadly and domestically. So that's one of our chief core missions, is to develop new clean tech products. We also have a mission to help our manufacturers here in Michigan become more efficient, reducing their energy consumption, reducing their emissions, and just improving throughput and operational expenditures by introducing technologies that reduce energy consumption, as well as just improve throughput, improve quality, and operating expenditures. So we help manufacturers with adopting Industry 4.0 technologies in a partnership with Lean Rocket Lab. We run North America's only Industry 4.0 accelerator, where we globally crowdsource the best technologies that will make manufacturing operations more efficient. And we also run a My Healthy Climate Solutions program, where we help with GHG analysis and sustainability plans for small to medium-sized manufacturers. We're very fortunate to have the support of state agencies like Michigan Economic Development Corporation and the Michigan Department of Environment, Great Lakes Energy, also known as EAGLE, as well as a number of foundations that support our sustainability and clean tech work. Next. And the Innovation Challenge partners that are partnering with us on this particular challenge are two major manufacturers in Whirlpool, a large international appliance manufacturer that's headquartered right here in Michigan, as well as Gerdau, a manufacturer of steel products that is also located internationally with headquarters in Michigan. And we're also very fortunate to have this sponsorship and support of Breakthrough Energy. Breakthrough Energy is both a venture capital and fellows program, and is known for Bill Gates, who's been behind the organization to help support clean tech products, as well as a heavy concentration on industrial decarbonization technologies. I see that Tom Nastis, if you can mute anyone that comes on as an attendee, if you wouldn't mind muting your speaker, that'd be helpful. Thanks. And then we're also very fortunate to have the National Renewable Energy Laboratory in Colorado, who has a heavy emphasis on developing clean tech products as well as industrial decarbonization. and again, MEDC and Eagle. Particularly, you want to thank Eagle, who helped fund this activity and support our ability to kind of help manufacturers, Whirlpool and Gerdau, be a part of this. Next. So this is the Centropolis core team that's working on the Industrial Decarbonization Innovation Challenge. Myself, you'll hear from Phil Swanson, who is our director of the program, as well as Riley and Gret, who played a big role in helping support the challenge. Next. And then we'll have a part of this program as well. You'll hear directly from our corporate sponsors. Scott Bummel, who is the Senior Manager, Global Sustainability Net Zero Program Lead for Whirlpool, will be sharing his perspectives on what Whirlpool's mission is and reducing their emissions and being more sustainable as a manufacturer of appliance products. We also are fortunate to have with Gerdau, the Regional Environmental Manager, Christopher Hessler, that'll be involved in the program as well. And then with NREL, we have the Advanced Manufacturing Laboratory Program Manager, Matthew Ringer, that can talk more about the laboratory's efforts in this area. And then Eagle, our sponsor, Environmental Engineering Specialist, Lisa Thomas, is also joining us. Thank you for being here. So we'll allow them to say a few words and then also make sure there's time for Q&A for you to ask questions of our speakers. Next. So why the focus on industrial carbonization, right? Many of you are probably not surprised to know that the industrial sector is a major consumer of energy. In fact, the last data that was out there published in 2021, the U.S. industrial sector accounted for 35% of the total end-use energy consumption and over 6,000 million metric tons of CO2 equivalent. Heavy processing, manufacturing like chemical manufacturing, refining, manufacturing of iron and steel and metals, cement manufacturing and food manufacturing are some of the largest consumers of energy and emissions. And in Michigan, we have quite a few manufacturers of all of those, and then some people are familiar, obviously, with our manufacturing of automobiles, appliances, furniture, and other products that go into medical devices. But it's really a lot of the raw material processing that go into those products that are also very prevalent domestically, and particularly in Michigan, as we have over 10,000 manufacturers in our state that consume a lot of energy and are doing their best to try to reduce their energy consumption and emission profile. Next. The state of Michigan, recognizing this and the importance of these manufacturers to not only help with our plans for climate change, but also by reducing their energy consumption, have a real opportunity to improve their bottom lines, right? So they set out to partner with industry and launched what's known as the My Healthy Climate Plan. And you'll hear a little bit more about this with Lisa Thomas with Eagle. But it was a directive to really focus on emission reductions across all areas, residential, commercial, and the industrial sector, and really reduce emissions significantly, 28% below 2005 levels by 2025, and reducing GHG by 52% by 2030, and achieving economy-wide carbon neutrality by 2015. A really aggressive measure, but of course, focusing on the industrial sector is a big part of ensuring that we can reach those goals by 2050. Next. So, many may not be aware of this, but manufacturers more than ever are really addressing their energy consumption and their emission profiles in their manufacturing operation. What you see here is three focus areas in particular that manufacturers are trying to address, what we call Scope 1, Scope 2, and Scope 3 emissions. Scope 1 emission are really the emissions directly associated with their manufacturing plants. So the on-site energy consumption and material processing and the energy use and emissions associated with that. many manufacturers have been working on this. Like I mentioned, it impacts their profitability, their ability to be competitive. Most of our manufacturers here in the state have, already switched to, retrofitting to LED lights and better insulation, more efficient HVAC systems, building envelope technology. And now we're getting more aggressive on reducing emissions in the processes, the manufacturing processes within their plants. And that's a big part of what we're looking for in a way of new ideas and technologies with the Industrial Decarbonization Challenge. And manufacturers here in Michigan that also have manufacturing outside the state, like Gerdau and Whirlpool, and outside the country, are increasingly being pressured by regulations in some countries, particularly the EU, to not only address their Scope 1 emissions, but also their Scope 2 emissions and Scope 3 emissions. So Scope 2 emissions is looking at the emissions from the purchased electricity for their own use. So manufacturers are trying to address this by adding renewables to their plants, like wind and solar and geothermal, and as well as buying renewable energy credits for renewable energy projects in and around the regions. And now Scope 3 emissions are being addressed by manufacturers, big and small, and that's really looking at the impact that their supply chain has on emissions. As any big manufacturer is going to have raw materials and components coming into their plant, so addressing how the emissions of their supply chain are trying to make impact and reducing those over time, as well as they ship their product out, how to reduce emissions from the downstream transportation and distribution, as well as end-of-life treatment and recycling of their products at end of life. Next. So that brings us to our challenge, right? How are our manufacturers to address these decarbonization aspects? And I'm going to turn it over to Phil Swanson, our program director of the challenge, to share a little more details about what we're looking for solutions, not just for Whirlpool and Gerdau, but many manufacturers here in our state that also need this support.
Yeah,
Phil?
Thanks, Dan. Yeah, thank you. So when we started this challenge and we started talking with different potential corporate partners, we really wanted to understand across scope 1, 2, and 3, what were the biggest opportunities for them to help decarbonize their emissions and decarbonize their industrial processes. And so as we talked, we started seeing a number of common themes emerge, and those turned into our challenge focus areas. The first being decarbonizing how we manufacture things. The second, decarbonizing the built environment. And the third, decarbonizing the supply chain. So, what does that exactly mean? So in terms of decarbonizing how we manufacture things, Dan talked a lot about kind of the scope 1 and 2 emissions in terms of, electrifying and producing items with new production processes that are net zero or even carbon negative. So here, our goal is to enable the use of clean energy in those production processes and make traditional applications switch to sustainable energy sources and improve the carbon capture. So some of the very specific technology spaces we're looking at are unique fuel switching technologies for traditional machine applications, potential breakthroughs in hydrogen fuel or electric boilers. For example, I was recently at a conference. Maersk had their first ammonia powered shipping container pull into port. Substitutes for natural gas equipment and methods to retrofit and electrify natural gas, as well as carbon capture systems for manufacturing procedures and plants. Another piece is decarbonizing the water heating process and technologies, as well as decarbonizing watering and moisture removal, and then affordable, scalable biofuel technology. So this is one, and there's been a lot of movement, a lot of progress, but the big piece is how do we scale these technologies and how do we actually have them be a net negative in terms of carbon reduction instead of sometimes adding additional carbon into the atmosphere through the processing. And then this one is very specific to decarbonizing or electrifying paint, curing, or drying ovens. So you can imagine during these processes, right, whether it be consumer products or others, as something is moving through the production facility, the amount of energy it takes to dry or cure something with a natural gas oven, how can we turn that into an electric process? Dan, anything you want to add before we move?
No, go ahead, Bill.
All right. Now, decarbonizing the built environment. This one is gaining a lot of traction, especially in the residential commercial space. When you get into the industrial space, how do we run and monitor the buildings we occupy, but also how do we monitor the energy we use in terms of the production? So we aim to make current buildings more efficient. And at the same time, when we build new structures, we want to make sure we do that without emitting carbon, and we're using carbon neutral or carbon negative materials. So additional examples, low cost energy consumption metering. A lot, like Dan said, everyone has, replaced their light bulbs with LED fixtures. They're LEED certified. They've done a lot in terms of HVAC potentially, but there's still additional opportunities for additional metering technologies and load balancing and getting very granular in terms of how we manage energy consumption. Dynamic supply balance across multiple energy sources. So you can imagine grid, wind, solar, and battery. How do we have those all work together so that we can optimize the energy efficiency on site and make sure that it's carbon neutral or carbon negative? Dynamic load balancing, which is, again, this dynamic supply piece. How do you manage that dynamic supply across the grid? Water monitoring and reduction. So how do we reduce the amount of water that we're using or reuse the water that we're using inside of a system? And then systems that heat or cool isolated work areas without having to impact the larger building. So think about those ovens I talked about. When those ovens heat up, how do we isolate those environments in those areas without impacting other areas on the manufacturing floor, as an example? And then additional breakthrough energy efficient building technology. So you can think of potentially solar retrofitted buildings, solar lined windows, new insulation technologies, new building material technologies, net zero cement, things of that nature that whether we're building, retrofitting, or managing an environment, how do we actually have some of these breakthrough efficient technologies? And the last part, decarbonizing the supply chain. So when Dan mentioned the scope 3 piece, you can think about shipping logistics, moving finished goods, but you move up the supply chain into those scope 2 and scope 1. How do we actually make sure the materials that we're using to build and manufacture new things aren't adding unnecessary carbon into the supply chain? So some examples of technologies we're looking for in this space, materials or product recycling and waste reduction technology. So if you can imagine the life cycle of metal moving through a manufacturing facility. How do we capture waste metal and get that back into virgin materials so that we can use it, reuse it again? This is talking about on-site scrap recycle and reuse, increase of non-virgin materials in manufacturing. So this can be a big piece around essentially carbon types of materials like plastics, et cetera. So how do we actually increase the recycling and turning of that into non-virgin pellets and other things that can be used in the product development and manufacturing processes, and then creating new materials and manufacturing processes that are carbon neutral or carbon negative. So moving away from just reuse and just non-virgin materials. How do we actually have substitute new materials? Whether that's hemp and other things. There's a million types of products that we've started to see moving into the market, but now we need to move to scaling these into the manufacturing process. So we're looking for those that can really be used in industry and help make an impact today. How can we recycle and reuse foams, whether that be insulation foams or packaging foams throughout the product life cycle? EPS, foams have been great in terms of their usefulness, but they are a potential scourge on the environment, right? Those things in the packaging space are very tough to eliminate. And now how do we get something that's cost competitive, but also carbon neutral, carbon negative in terms of our supply chain and the environment? Also, how can we reuse parts of returned products that can be recycled in the manufacturing process? So think about when you have a refrigerator or any other kind of product that reaches its end of life. How do we make sure that product and the components inside of it are able to potentially be recycled into that manufacturing process, whether that be refurbished product or saying, okay, actually these components can now be moved back into the production process. Also, how can we utilize a digital passport to improve the circularity of our products for supply chain transparency? For those of you that are familiar with some of the EU legislation and regulations, they're moving very swiftly to commonize a digital passport so that a consumer can see, okay, what is in what are in the products I'm purchasing, and see kind of the digital supply chain footprint or fingerprint of the products that they're buying. So this, puts a big onus on manufacturers across, supply or across scope 1, 2, and 3 to say, okay, I need to be able to trace that through the entire supply chain. So why do this challenge, right? So these are the focus areas. What are the benefits for you, the startup, in participating? So obviously the first and most obvious is the acceleration of commercialization opportunities with 250K in paid pilots. So the idea that you're going to be able to have direct access to the decision makers at these organizations is a huge benefit. One thing that Dan and I and others at Centropolis and the accelerators we work with, we like to talk about is, one of the benefits we have because we have such a direct line to a lot of the decision makers inside of organizations. We cut through the noise. You can poke all you want at some of these Fortune 100, 200, 500 companies, but how do you actually get connected with the right people that then can engage in a pilot? The goal of this is to connect you, the best opportunity so that you can get to that phase and take advantage of these paid pilots. The access to experts and mentors. So, having NREL, having some of these other organizations like Breakthrough Energy, you have direct connections not only to our experts at Centropolis, but industry experts and commercial partners to discuss and ask questions about these potential areas. And you get to learn from the best, and brightest in these different industries. So it not only is a great commercial opportunity, it's a great learning opportunity and helps you grow as a startup and understand, hey, where's really my product market fit? What is my opportunity to scale and can help you grow as a company? And then additionally, accelerate development. So you're going to have access to tools and networks to accelerate that development. In terms of, Centropolis, we have, like Dan said, we have this internal manufacturing, design and engineering and scaling capability. And having that additional access to those tools and resources can help you move the needle and scale commercially and accelerate some of the development you've been working on. Dan, anything you want to add?
I think, Bill, you did a pretty good job of wrapping up. What we're going to have is a real opportunity specifically with Whirlpool and Gerdau to help execute on pilots that they deem are going to potentially benefit their operations. But we're also going to be looking at other technologies that I think have a broader appeal to manufacturing industries and try to work with Eagle and other manufacturers to see if we can have those technologies adopted in, let's say, food processing or cement manufacturing, if the ideas that are proposed are a better fit for certain industry sectors. Just wanted to clarify that.
Yep, no, makes a ton of percent. And then the one thing too, you can see there's additional access to capital through the pitch day that I'll go over here in our schedule here in a second. So the application process, where are we? Right now, we've opened applications. Many of you actually have already started applications in the SXS platform that we're using to receive these. So again, applications are going to close on November 30th. That's the last day they're going to be available. The submission portal for SXS will close at midnight Pacific Standard Time. So if you're on the Eastern Seaboard, you technically have till 3 a.m. the next day. Once we have those submissions are finalized, we'll have our review panel of experts. We'll review these for technical feasibility, and we'll down select those for review by our sponsor organizations. With those, we'll schedule one-on-one meetings in January with the down selected participants to better understand the best fit and further narrow down the applicants, which will then move to the finalists being announced in February. We'll announce these via webinar and list them on our website. And then we'll have a final pitch day in March and April for those finalists to pitch and have access to additional capital, be in front of additional investors from angels, VCs, CVCs, and others, and additionally find broader partners in the manufacturing ecosystem here in Michigan. Dan, anything you want to add?
No, we're good, Bill. Thanks.
And so if you are, many of you may be familiar with the application platform, but it's called F6S. It's very commonly used. Many accelerators across the country, across the world use it to manage intake. So we have an application form that's pretty straightforward in there. The platform allows you to start and save a draft. And so usually what happens in terms of timeline, we get a lot of applications started, and then a week or so, 2-3 weeks or so before the challenge ends, we start seeing a lot of those final applications come in. If you at any time have questions about your application, don't hesitate to reach out to the team, asking about specific details, about your technology, best fit, just questions. We can answer those through the platform. We can answer those via email. So don't hesitate to reach out if you have any questions in terms of just how does the application actually function. So yeah, so before we jump into introducing our challenge partners, is there anything, Dan, that you want to add?
We had a couple questions come in. So the first was, would university projects fit, or is this solely for startups and small companies? This is open to all. So universities can present a solution that they may have for industrial decarbonization. This is also open to startups and established small businesses, medium-sized businesses, really anyone that has a relatively, unique solution around the topic areas, the innovation challenges that we're looking for. What I would say is that very early stage technologies like TR level, 1 to 4, early research development, proof of concept is not what we're looking for. We're looking for technologies that have some proven validation that they work in a manufacturing operation, and that are ready to be more widely deployed is what we're concentrated on.
Yeah, and the one thing I will add, if you, when in doubt, I would say apply. One of the things that we have the advantage of at the accelerators, we have a bunch of other programs that are potentially good fits for earlier stage ideas and organizations, or even research. And then if we do say, hey, this is something that's interesting, we can connect you with somebody who could help you scale, commercialize, and potentially further your opportunity. It just wouldn't be a potential fit for this particular instance, but it does get you on the radar, and it doesn't mean that we won't be able to help you in some way.
Yeah, and even earlier stage technologies, we like to know about them because we could help support through our C3 accelerator the development of them to the point where they are commercially relevant and would be a fit for deployment down the road. So we had another question: how do you weigh the impact to the greater Michigan economy in the application? So a lot of this is being driven by the My Healthy Climate Plan's goals, as mentioned, to reduce emissions significantly by 2025 and get to economy-wide carbon neutrality by 2050. So each solution that comes in, we're going to be looking for some relevant understanding of the emission reduction that this would present to our corporate partners and to our manufacturing base here. But we're also looking at other economic development benefits. So if the company's technology is successful and could be widely deployed, not just with Whirlpool and Gerdau, but more broadly across the manufacturing sector, could that industrial decarbonization product be manufactured here in Michigan? And, could it have an impact on the local supply chain and the company that's producing it? So we're very much looking at this from an economic development lens as well as emission reduction impact.
Yep, and just to add further color, our reviewers have a scorecard that they're using, and in terms of overall emission reduction and potential, that's a key component, as well as fit for the challenge, and then fit for individual sponsors, in which Eagle is one of those. So Eagle is concerned about overall economic impact in statewide versus just one specific industry. So it is an important consideration for our applications. So first up is Whirlpool with Scott Blommel. I'll let Scott take it away.
Hi, good afternoon, everyone. First off, just a quick introduction. Just really excited to be part of the Decarbonization Challenge. We've had some success in some previous interfaces with the accelerator in Industry 4.0 and automation technology. So really excited about the opportunity now to help us with our net zero journey and our decarbonization plan. Just real quick, the kind of perfunctory, who is Whirlpool? For the potential participants, $20 billion company. We've got 7 brands with over $1 billion in revenue, 61,000 employees, and then probably most importantly for this activity is 56 manufacturing and technology centers, all of which are looking for opportunities for decarbonization. So fairly widespread across the globe, and really our largest I guess carbon emitters are in the U.S., so it is pretty NAR focused. But excited at plenty of opportunity in the company and in the region. Just real quick, our products: dishwashing, refrigeration, cooking, laundry, basic appliances. Next slide. Yeah, so 2 years ago, our CEO, Mark Bitzer, did announce our commitment to achieve net zero scope 1 and 2 by 2030. We also have a 20% reduction in scope 3 externally communicated as well. So that's kind of the background of the reason why. We are well on our path. We've probably achieved over 50% reduction from our 2016 baseline already, so we're well into it. This year actually is a very critical year on our roadmap. Next slide. Just in general, we look at our sustainability throughout our full life cycle, upstream in product design, materials management, through material use and impact, and even responsible sourcing. And then what I'm focused on primarily, and what the discussion today is around, sustainable operations. Obviously, GHG emissions, decarbonization is a big part of that. And then even downstream with our products in use, which honestly is our largest scope 3, almost probably 80% of our total carbon footprint occurs once you plug the appliance in. And then, of course, end of life. So we look at sustainability across all those vectors. And then real quick, as far as how we're approaching our decarbonization and net zero, it really starts with reducing our overall energy use through our world-class manufacturing pillars. We have an energy pillar strictly focused on reducing energy. So really interested in those kind of opportunities from the decarbonization challenge that are around energy management and energy reduction. And as Dan mentioned, electrification and substitution is a big pillar as well. So a lot of activity around hydrogen, potentially substitution of natural gas processes, electrifying where we can, and then replacing that electrification with renewable energy. So we have 5 plants currently with renewables on site, and we are looking to expand across all those. So that's a lot of generation on site that we would be interested in understand how we can balance. So some of those technologies Phil mentioned around how we balance our generation versus our consumption. And then finally, we will probably need some level of carbon capture projects and high value carbon credits just to close out our net zero commitment. Hopefully it's going to be less than 10% of our total from our 2016 baseline, but we are interested in evaluating those types of projects as well. So that's kind of how we're approaching our net zero and really are interested in decarbonization.
Awesome. I believe next is going to be Chris from Gerdau.
Good afternoon, everyone. Can everyone hear me?
Yes, we can hear you, Chris. Thank you.
We've had so many microphone problems with this computer. I just wanted to make sure. So for those of you who aren't familiar with Gerdau, we are one of the largest steel manufacturers across the Americas, North and South America. At this point, we've got nearly 100+ facilities overall across 2 continents that are focused primarily on steel manufacturing and metals manufacturing, which in and of itself is an industry that's been called out as traditionally being a high-risk industry, a heavy polluting industry. But here in North America, we always like to call out the fact that Gerdau strictly focuses on electric arc furnace technology, which is the lowest emission process for producing steel in the world, in comparison to things like blast furnaces, oxygen furnaces, integrated steel manufacturing. So even despite our focus on leveraging EAF technology, our CEO and board of directors based out of Brazil has thrown a commitment out there for our entire organization that we will reduce our global greenhouse gas emissions from 0.93 tons per ton of steel we produce down to 0.83. That's a global commitment, and that includes the fact that we've got integrated mills in Brazil that very much so push that needle. Here in North America, GSN, which produces steel predominantly for the automotive industry, safety critical applications, and other very specialty and niche applications, We're already meeting that goal. But despite that, we're putting our own goals and targets out there to reach a target of net zero emissions by 2050, which for the steel industry, 2050 can't get here fast enough. And it's also getting here way too fast. We're looking at we're going through global planning activities that to study our emissions, study their sources, create engineering and capital plans to reduce emissions across all of our facilities here in North America to reach that net zero goal by 2050. I often joke with people, we're going to get there, but understand the fact I'm probably going to retire 10 years beforehand. So we're going to be handing a lot of this off. But it's ambitious and it's audacious, and we're excited to be a part of that and be one of the leading companies in the Americas regarding environmental performance. So things we're looking at right now here in our short term, as we're reconceptualizing our process and our technology to be a net zero company, we're already offering some net zero steel products to our customers. We've gone through and leveraged some of our accounting, bookkeeping, as well as renewable energy credits to offer that as an option to our customers that are needing to meet those goals. Over the past 3 years, we've invested nearly $500 million in capital to improve the environmental performance of our steelmaking. And that was not a trivial process. And actually, as a net, as a net result of that, we can directly trace those capital investments down to a 50% reduction in natural gas use, which goes directly towards our Scope 1 emissions, and another 15+% in a reduction of carbon sources used in steelmaking, which is also going against our Scope 1 emissions. As the result of that, we've reduced our overall carbon intensity of our steel here in North America by 33% since 2020. That's something 10 years ago I don't think any of us would have said was even possible. But we can look at the results now, do the math now, smell check it to each other, and actually all look at it and go, wow, 33%, we actually did that. That's tremendous. And still kind of unbelievable despite the fact that we did it. But looking ahead, we know our journey is not over. We have a long way to go. At 0.58 tons per ton, that's still a lot of emissions to reduce from our footprint. So one of the things we're really interested in is hydrogen. We always, in the steel industry, you always look for the heavy hitters, and hydrogen as a replacement for natural gas is going to be the future of the steelmaking industry. Even if we have to drag ourselves through it kicking and screaming. So we're already working on engineering to convert natural gas-fired processes over to hydrogen technology and validate that we're actually able to do this in a highly cost-effective but also environmentally friendly manner, which means one of our key needs over the next decade to 15 years is going to be how to better produce hydrogen, how to better use hydrogen, how to recover products of hydrogen combustion so that we're not just replacing one environmental issue being greenhouse gases with another issue being things like management of excess water, emissions, condensates, and things like that. We want to make sure that our operations in leveraging hydrogen can still be cost effective, because that's something that matters to our customers. In addition, we know, I threw it out there earlier, electric arc furnace steelmaking. The key component of electric arc furnace steelmaking is electricity. And I don't think I'm, spilling any trade secrets here when I say we use a lot of electricity. We are one of DTE's largest customers in Michigan regarding electricity usage. So we need to figure out, how can we reduce that? That's our Scope 2 emissions. And there's not a lot we can do about that unless we're ready to start buying up huge chunks of Monroe County and set up windmills and solar farms. We have to understand, and we need something to eliminate those greenhouse gas emissions from Scope 2. To kind of put a comparison on there, Our South American operations are typically 2/3 Scope 1 emissions to 1/3 Scope 2 emissions. You get to flip-flop that in North America. Why? It's because of the composition of our energy grid. We need to reduce the carbon intensity of our Scope 2 emissions, and we're not going to get there just through our utility providers. Their integrated resource plans call for them to do certain things to make sure they're meeting all of their customer demands and grid stability. We as a manufacturer trying to reach net zero emissions, we need additional solutions to eliminate the effect of those Scope 2 emissions. And that's something we know we need to be focused on over the next 20 years. Next slide. And this just gives an idea of the investments we made for people who aren't familiar with EAF steelmaking. These are two images from our most recent CapEx project here in Michigan to completely upgrade and overhaul our steelmaking process, including a new furnace, a new metallurgy furnace, as well as a new caster. And all of these things, as a net result, have resulted in us eliminating 33% of our emissions from the bottom line. And we call that a good start, as audacious as it is.
Awesome. I think next up is Matt Ringer from NREL. Thanks for that, Chris. Great job.
Hey, everybody. Hope you can hear me. Sorry for the challenges getting on Phil and Dan, but thanks very much for having me. Some of you on this call will wonder, why is a national lab interested in these areas? And I think it aligns very, very well with the work that the National Renewable Energy Lab is doing in this space. My name is Matt Ringer. I manage our advanced manufacturing program here, which means that I work specifically with the Industrial Efficiency and Decarbonization Office and the Advanced Materials and Manufacturing Technology Office within the Department of Energy. At NREL, there's a lot of things that you need to consider when you look at industrial decarbonization writ large. A lot of technologies need to be scaled up and deployed in order to meet these 2050 targets that the administration and the Department of Energy are looking for. So this slide is just meant to demonstrate how we think about industrial decarbonization. First of all, when you look at to 2050, what are we going for? What are we striving for as a lab and as a department? We're looking at carbon neutrality. We're looking at that while having a resilient domestic industry, meaning that we want these things to be done here to enable a workforce within the United States. We want that workforce to be able, and we want to make sure that we have secure supply chains. These are really, really important things to look at for 2050. Now, how do you get there? So we've kind of taken a little bit of a three-pronged approach to get here. First of all, you look at the near term, there are integration opportunities. There are green electrons for electrified processing on the grid right now. They are very location specific, and sometimes the process technologies that handle them aren't always equipped to handle the electrons that may vary over time. So looking at opportunities in integration for electrified processes is one area that we see as a very important research opportunity. Specifically, you can look at power electronics, which is not something you think about for industrial decarbonization, but how do you make them and how do you put them into place and allow that they are operating resiliency over a long term? How can that be done? That is a question that we are contemplating with novel wide bandgap devices, but it's also things that are really important when you look at a variable renewable grid. The second thing is when you look out 5 to 15 years, well, you're going to need to make more devices that make green electrons. So you're going to need novel photovoltaic technologies. You're going to need the processes to make those technologies, and you're going to need the wind turbines and the energy storage systems to enable more green electrons out there, so that if you go to an electrified process, you start looking at things where you're utilizing carbon dioxide, you have these technologies available. And that's kind of what we look at as the make aspect of our strategy. And then finally, when you look at 15 to 25 years, which is really where some of the novel concepts are going to start going to be seen, be it making sustainable aviation fuels, looking at carbon dioxide conversion technologies and absorption conversion technologies, how you can use that carbon a second time, recyclable by design technologies. These things start coming into play in that longer term. We are interested in working with people and seeing those technologies get developed, as we are as looking at the nearer term opportunities. So that's a little bit of how we think about it at a national lab. We know that Dan and the team are very equipped to making impact with companies, and we're looking forward to see what kind of ideas come through so we can really make these 2050 goals happen. So that's what I got to say. Thanks a lot.
Thanks a ton, Matt, for jumping on. And then last but not least, Lisa Thomas with the Eagle.
Thank you, Phil. Hi, everyone. I'm Lisa Thomas. I'm one of the program managers with the Energy Services team at Eagle. Energy Services provides a variety of programs to support Michiganders, businesses, and communities in reaching their own energy goals. We also create programs such as this to support the governor's initiatives, such as the My Healthy Climate Plan. There are funding opportunities for the industry sector. Some are called the Small Manufacturing Retooling Program, which offers matching grants to small manufacturers located in Michigan to implement energy efficiency and retooling activities. The other program we have is the Agriculture and Rural Businesses Energy Incentive Program, offering financial incentives to farms, ag businesses, and rural small businesses for energy-related projects. And of course, we have this industrial challenge with LTU. The other programs that you may also find beneficial is our clean energy assets roadmaps. The roadmaps contain both the clean energy technology adoption and renewables. These roadmaps help identify, evaluate, and provide detailed opportunities to significantly accelerate our sector growth. We also have the Clean Energy Assets Database, which is a free resource for elected officials, government employees, business owners, planners, developers, Michigan residents, industry, and as well as commercial sectors. The state of Michigan does participate in the U.S. DOE Industrial Assessment Center, which is currently being held by Michigan State University. The MSU Industrial Assessment Center helps small and medium-sized U.S. manufacturers and commercial buildings save energy, improve productivity, and reduce waste by providing no-cost technical assessments, which are conducted by students and faculty at MSU. I will also say, please visit our webpage to find the funding opportunities and resources that you may need. We are in the process of opening up applications for the new fiscal year, so please check our websites for any updates that we may have.
Thanks a ton, Lisa. Yeah, and so with that, please, if you have any additional questions, drop those in the chat right now, and we can potentially answer those. And then also I put my email in the chat as well. So if you have a question that you think of, don't hesitate to reach out to myself, and I'll make sure to connect you with the right person that can answer that if I can't provide you with the requisite answer or the appropriate answer. But yeah, Dan, anything else while we wait? Some questions jump in while we wrap up?
Yeah, I just wanted to point out, I think, and our sponsors did a really good job of kind of sharing their perspective of some of the steps they've already taken and what they're working on. So as we get into this discussion, I think it's, I encourage anybody to ask questions, because there's really 4 ways to get at industrial decarbonization. And if you look at the Department of Energy's industrial decarbonization roadmap, it's in 4 areas, right? First of all, making manufacturing operations more energy efficient. We've talked a lot about that, right? And that's making building operations better, but that's also working on process energy efficiency, like I talked about. And that there's a lot that's gone on into industrial Internet of Things, and what we call Industry 4.0 is one way to get there. And I'd like to have Whirlpool and Gerdau share their perspective. And then it's also in a second area, trying to electrify processes that are using higher carbon, fuels, including natural gas, right? There's, as you pointed out, Phil, there's a lot of manufacturing equipment, autoclaves, furnaces, paint booths that use natural gas or petroleum-based fuels. And the theory is, again, if we get to significant renewable power generation across our country, eventually, that if we're using electrified processes like Gerdau is with electric arc furnaces, that we will be carbon neutral. Then there's a third area of low carbon fuels, right? Using clean or green hydrogen, bio-based fuels. And then a fourth is the carbon capture, utilization, and storage, right? Within the plant that Matt brought up. So it might be a good idea to kind of talk a little bit about that. What the first thing I wanted to focus on, and this is a direct question for particularly Scott and Chris, is we're seeing rather significant energy reduction and therefore emission reduction just in introducing, industrial Internet of Things. So that means putting sensors on every piece of equipment, not just machining centers, but assembly equipment, PLCs, and conveyor belts and that type of thing, and idling that equipment when not in use. Sometimes 10, 20% energy savings. Can you guys talk a little bit about some of the measures you're taking on process energy efficiency and adoption of I4O technologies and how that supports that?
I can give a quick introduction and maybe Chris can follow up. But yeah, I mean, we have two kind of complementary programs going at once. One of them is with our world-class manufacturing operations and the energy pillars, which has an 8% reduction year over year. So they're constantly striving for ways to, number one, identify opportunities, which requires good data collection, good data availability, and then to your next level, once we can connect some kind of control through Industry 4.0, then we can start automatically adjusting. So those two programs, whether it's WCM or our digital transformation, Industry 4.0, are kind of working in conjunction together to provide, number one, more data clarity, and then number two, potential control and reduction year over year. And we've seen, we continue to see benefits from both working together in parallel to try to identify where to work for sure. And we have invested quite a bit in building management systems, boiler, chiller controls, VFD drives, those kind of technologies all kind of go hand in hand with that initiative.
Yeah, I'll follow up with what Scott was saying there and say yes. Over the last several years, this idea of data acquisition and leveraging the Internet of Things between our sensors and control modules has given us a tremendous amount of visibility on how much energy we're using, what type of energy we're using, and what those relationships are. We're resource intensive on that side in terms of natural gas and electricity. So our finance departments and CFO are really keen on making sure that we are getting every dollar possible out of that and not wasting any. And they are not bashful about asking those questions when the numbers don't jive with what their expectations were. But there's a benefit there. I mean, the visibility we can create through those technologies in our process, kind of stuff you would have never thought 10, 15 years ago. Even going back to some of my own field work, when I look at the resources that people have available today, it's mind-boggling. And we've only really scratched the surface of the potential. I think one of the key things looking out there at new technologies that I keep questioning, and I look at our own business development divisions, how can we leverage AI over the course of the next 10 years to really optimize and predict how we're using energy, when we're using it, when we should be shutting down idle processes? How do we sit there and leverage that technology within normal industrial control schemes, which has been dominated by companies like Siemens and Allen Bradley for, well, probably as long as I've been on the earth? What's the next step? What hasn't been introduced yet to industry to help us get there? Something adaptable, something that we can learn with to help us improve our energy management, because I don't think any large manufacturer in the world couldn't put a multi-million-dollar price tag on that, just on how much we would save. So I really, we're doing way better now, and I love the results I'm seeing. I'm just really encouraged by what the next step is.
And then maybe one additional wrinkle, just as we add more renewables, in the mix, and how do you balance that energy management as well to kind of lower your overall demand, and when do you run renewables versus grid, and how you interact those two together. It's another layer of complexity, but also opportunity.
Thanks, Scott, and thanks, Chris. Matt, can you talk a little bit about some of the work you're doing at NREL and in these kind of 4 bucket areas, I think, and what you think is kind of the promise, especially as we can find more affordable solutions for delivery of green, clean hydrogen, and CO2 sequestration within the plant? Is Matt?
Oh, Matt,
Oh.
you're muted.
He's muted.
Such an idiot. Anyways, normally when for us, we're looking at 3 different areas. Okay, when I showed my slide, we kind of talked about time frames, but when you look at the technology impacts, I mean, the one you talked about with hydrogen, because its ability to be used, be stored, be converted, all these different things make it a really interesting paradigm. We have up at our Flatirons campus, we have an electrolyzer system coupled to an energy storage system that we're exercising with green electrons. So we've got wind and solar and grid connectability to see how it works in that integrated system. Okay, so that's one thing we're doing, not the least of which is contemplating how that hydrogen could be used in future fuels. When you look at carbon dioxide, okay, there's the idea of being able to pull it from the atmosphere and then put it underneath the ground, right? These are 2 areas. We're very interested in the use of carbon dioxide, right? We realize that it can be captured. We realize that it can be put underground and stored. Our interest is, how do we use it? How do we take it and do something with it? So that's really important. And then finally, when you look at the electrification of processes, now, just because you electrify a steam boiler, for example, doesn't mean that it's going to be decarbonized in the near future. You have to couple that with the expansion of renewable assets on the grid, right? And that is something that we're seeing. So when you talk about some of the discrepancies that you have between looking to a 50% or looking to the 2050 goals and creating electrified processes, obviously DOE is saying that we assume, the Department of Energy is saying that we assume that there'll be more green electrons on the grid that will allow us to decarbonize these processes, because otherwise just electrifying them now with the green mix doesn't get us there. Making the technologies electrified allows us to be ready as the green grids over time to really get those carbon impacts into decarbonize industry. So hope that answers the question, Dan, a little bit from our perspective.
Yeah, it does. Thanks. And it brings me to the point that I think is really important, is that the hope is that maybe there's, hydrogen pipelines to every manufacturer down the road, or, but that infrastructure is not there, right? So
No.
if a manufacturer wants to move to clean or what we're calling green hydrogen as a input, they either have to manufacture it on site through steam reformation, ammonia cracking. They have to, or if they're blessed to have a hydrogen source in their production process, but many are not. And it's, for Scott and Chris, talk about that as a manufacturer, you want to move in that direction, but you also, natural gas is cheap and it's abundant and it's available. And you have to be profitable as a manufacturer. So making that balance is important. So maybe we'll start with Scott.
Yeah, it's an interesting quandary because, as I mentioned, our energy teams have a cost reduction goal of 8% per year. So their biggest focus is always going to be reducing the electricity bill as opposed to targeting natural gas. But for our decarbonization, our scope 1 is our biggest issue because we have solutions for our scope 2. So it does come in a bit of a conflict with cost goals. to address your scope 1. As far as hydrogen use, we are actively replacing all our propane with either electrification or hydrogen in the field plants. So we do procure green hydrogen for that purpose. We are adding quite a bit of renewables on site that could potentially also come with an electrolyzer to produce hydrogen in the sites that we use hydrogen. So I think there's kind of a natural progression to as you find opportunities to use hydrogen in your processes, perhaps you can generate through renewables. But that's a cascading effect and a lot of capital required for something like that. But correct.
Yeah, I think, Scott, that's a good point of how do we align these, right? Not just across and inside of the organization, but across public-private sector, right? So we make sure that the funding and things are available to make sure that are now aligned incentives, and we can actually move forward so that we're not just electrifying processes to do it. We're actually doing it on the right way, making sure that we're making a carbon negative solution versus just moving say carbon the carbon around.
Yep.
So I think we're close. We're up on time here. Dan, any final words before we wrap up?
So for those that took the time to join us or be watching this webinar at a later date, just reach out to us, as Phil mentioned. If you're not sure if your solution qualifies or would be a good fit for Whirlpool, Gerdau, or any of our other manufacturers here in the state, reach out to us. We'll have open office hours, and we'll try to work with you to make sure if an application makes sense. And our best interest is to help our manufacturers be more efficient and reduce their emissions and improve their profitability and their global competitiveness. So bring everything you can to us. And I also want to thank again Scott and Chris, with Whirlpool and Gerdau for being our manufacturing partners and sponsors on this program and for making time today to be on this webinar. Matt Ringer with NREL, leading national lab in this area. So grateful to have them involved. In fact, we're expecting that some of the projects that come our way may need testing and validation services that are uniquely available at NREL. So Matt, thank you very much for your participation. I also want to thank Breakthrough Energy fellows and the team there that agreed to sponsor this program, and then our state agencies, Michigan Economic Development Corporation and Eagle. Lisa, thanks for making time today to address the audience and for contributing to our challenge.
Yeah, thank you, Dan. And so with that, we'll be closing the webinar, but look for an email with a recording, the slides, and also we'll be including a link to the office hours. So we'll have set hours available that you can register to talk to myself and others with your questions. So we'll have those available every week for people that they can schedule. So again, thanks for your time, everybody. Enjoy it. Have a great weekend. And until we talk again, take care.